All right, so topic 3.12 is very short, and it just deals with the equations regarding wavelengths and energy, and it's pretty straightforward to understand what is going on in in these kinds of problems. So this is going to be really short. I only have two examples for you, and again, it's just using these two problems, which are on your formula sheet, where the speed of light equals the wavelength times the frequency of the light. And then here, where the energy equals Planck's constant, which is on your formula sheet, times the frequency of the light. And again, you can see all of this right on your formula sheet. If you look on the section that says atomic structure, it's right here. And you can see on the right side it tells you, right, that the upside down Y, I can't remember the official name of that, is wavelength, V is frequency, E is energy of light. It gives you Planck's constant, which is h, and the speed of light, all right there. So if you have those, these are really straightforward. I mean, these are some of the most straightforward problems, I think, in AP Chem. So in an experiment, the first one, an experiment, a photon with a frequency of 7 times 10 to the 14th power uh, s to the negative 1, which means that many times per second, that's the frequency, was absorbed by a sample. What is the approximate energy of this photon? So we have our two equations, right, that we can look at. Which one are we going to be considering? Well, we want the energy, and we have the frequency, so we can say the energy is going to equal 7 times 10 to the 14th power, which is, in this equation, the frequency times Planck's constant, because Planck's constant times the frequency equals the energy, which is 6.626 times 10 to the 34th. We put that in our calculator and we get A. That's it. It's not a long process. Then we can look at one more, like this. So, which of the following is closest to the frequency of the light with a photon energy of 3.3 times 10 to the negative 19th? So we can say again that E equals h times V, and C equals the frequency times the wavelength. And so in this case, it's asking us which of the following is closest to the frequency of the light with a photon energy. So it gives us the energy. So we can use, again, this equation here, energy equals Planck's constant times V. And so if we do that, we get 3.3 times 10 to the negative 19th equals 6.626 times 10 to the negative 34th times V. And we solve for V, which equals 5 times 10 to the 14th power, which is option C. If they asked us for wavelength after that, then we would just say, okay, C equals the frequency times the wavelength, and plug in the frequency given. C is a constant on the page, and we could solve for wavelength. So that is topic 3.12. There's not a lot to it. So if you see a problem asking about frequency, wavelength, energies, don't freak out. Just refer to these formulas, look at what each of the things stands for, and follow it through.